Okay, so essentially you guys all are aware of now. I mean, just for the sake of completeness, what do we know? What do we need? What do we need to deploy SAN Analytics is a 32 gig capable MDS switch. That's number one. You need a supported NXOS version. You need the right license, otherwise you can get started with the trial license, which is there by default. You don't need anything else for that. And then you need a receiver, right? If you want to visualize the data. Otherwise, you can just get happy with the on-switch CLIs. Okay. Uh, the official two supported, the two officially supported receivers or applications are DCNM SAN Insights and the Vertana Virtual Wisdom that you guys saw yesterday. For NXOS version or DCNM version, always check the release notes. These slides will get dated eventually. Will not come and update these slides every time with every version. So refer to the release notes. That's the standard procedure. Okay, availability of flows. I mean, we have talked about this. I'll not cover every little detail, but essentially the point is your traffic must pass through a 32 gig capable port at least once in the end-to-end data path. So there are some examples here, right? Like when we are comparing a 16 gig module to 32 gig module. If you look at scenario F, the two flows that we have there, actually end-to-end we have 16 gig modules, so we'll not get analytics there, or we cannot enable analytics on any of the ports. But some other scenarios we have, the especially combination like E or combination like D, where the end-to-end IO passes through the 32 gig capable port at least once, and that's where we can enable it and inspect the traffic. Right. I hope by this time we all are clear that why it's enough to enable SAN Analytics only once in the end-to-end data path, because it's the same IO that gets initiated by the servers and then goes all the way to the storage and comes back. Okay, so a couple of points before we start looking at some diagrams. Number one, analytics is enabled per port, right? So, it's you cannot say that, collect metrics on some of the flows on that port and do not do for some other ports on other flows on the same ports, right? You can obviously enable or select or enable or disable it for a selective protocol only. You can just say SCSI or NVMe, but still the command is per port. Okay. The second bullet, I already explained that, it's not per flow. Right, which simplifies it, by the way, because that's what our competitor does. They say that you have to define a flow before monitoring it, and I think that's the biggest challenge, is because people don't know what to monitor, right? And here our idea is that you don't worry about what to monitor. Once you enable it, we'll collect the metrics and we'll figure it out, right, like where the problems are. I think that is the biggest differentiation, that do you know where the problem is, or do you not know where the problem is, right? So this is where the reality is, that how do we enable it, the simplicity part of it. The third bullet is designed for maximum coverage, right? And I'll cover more details on that. And also the configuration limits of other features are not impacted, like floggies per switch, floggies per line card, FCNS entries, and etc. Analytics has its own scale limits that I'll talk right next. But you should always refer to these configuration limit documents for detail. It's all available there, because things change with every soft release. Okay, talking about scale limits of analytics, the NPU, right? Just the NPU, because there are other factors too, like DCNM is there too. But just on the switch, we have the NPU that collects all the metrics from the IO flows. So there are two major scale attributes there. Number one, the number of ITL or the ITN flows per module and per switch, right? Why per module? Because we have one NPU per module. And why per switch? Because eventually the supervisor has to handle everything, right? Eventually the supervisor has to export the metrics. So that's why we have the overall limit. And the limits are soft limits, right? Even though we say per module we have 20,000 flow limit, and then per director class switch we have 40,000 flows, we have customers who are running more than that, right? Some customers are hitting 60,000, 80,000. Why? Because The 20,000 and the 40,000 limit is a soft limit. It's a QA certified number. It's not a hard limit. Okay, and because of that, when we design, our aim is that how do we spread the load evenly, right? Because one NPU per module, 8 NPU plus for 9710 or 80 or 16 NPUs for 9718s. That means if we distribute this capacity uniformly across the fabric, we can actually do a lot, right? But we have to do that. Okay, when we talk about 9700s, analytics can only be enabled on the 32 gig FC module. Not a surprise. Other modules can coexist in the same chassis. No restrictions. That's the standard 9700, value. One NPU per 32 gig module. That means all the 48 ports on that 32 gig module actually are backend connected to the same single NPU. And that means the NPU between two different modules do not talk to each other. Okay, there is a kind of distributed architecture, but this is not a clustering architecture. These NPUs don't talk to each other, right? Also, there's no dependency on the SOUP 1 or SOUP 4. SOUP 4 is what we launched last year, right? So the analytics capability is same across SOUP 1, SOUP 4, or Fab 1, Fab 3. Okay, about the fabric switches 9132T, 48T, and 9396T is we have one NPU per these switches. So you can obviously argue that for 9132T, we have just 32 ports and one NPU, and for 9396T, we have 96 ports and still one NPU. So you can totally argue that, right? However, the scale numbers are same across the fabric switches. That's 20,000 flows. That's a QA certified number, just to be clear one more time. And you should always refer to the official latest release documents or configuration limit documents for the best information. All right, deploying models.
Hey, Paresh, Mark, real quick. If a device, a T-switch is in NPV mode, you could still get a good collection, right? Is that an accurate statement? Okay.
Yes, we support SAN analytics when the switches are operating in NPV mode also.
And okay, yep, thank you. Thank you.
Doesn't make a difference, Mark, at all.
What's that?
It doesn't make a difference at all if the switch is in NPV mode or not.
Well, just the reason why I ask is when we're in NPV mode and there's no analytics, then we're limited to what's at the end port as to what we could see with that port trunks. And that's the reason behind my question. You get that, right?
Yeah, I'll talk about that. Like, there is a design diagram that I have that.
Okay, no worries. I just wanted to clarify for my own self. Thank you. Okay.
Okay, so deploying models on a very high level, analytics can be enabled on storage ports or ISL ports on host ports. Actually, there are very few limitations on what ports you can enable and what ports you cannot enable, right? This has very, I would say, strong value for those customers who are migrating from 9500s to 9700s, or for customers who are migrating from 16 gig infrastructure to 32 gig infrastructure. Because what it means is a customer who has an existing 16 gig deployment, they don't need to move to 32 gig if they don't have to. That's their decision whether they are ready to move to the next speed. However, if they want to adopt this capability of SAN analytics, what they can do is just get as many the 32 gig modules as required and then insert them strategically so that their end-to-end traffic inspection happens on those modules. So if you take the example of storage ports, in that example, I've got 5 9710s, and every 9710 has 8 modules. So that means I've got 16 gig modules there. I can probably get maybe 10 32 gig modules, 5 on each storage edge switches, and then throw them there, connect my storage, and get the end-to-end visibility. I don't really have to buy the new switch. I don't really have to buy all the 40 new modules, and I can still continue using the analytics capability, right? So that's the value here, right? Also, some customers may use the high-speed ISLs too, and or we can have it on host ports. Okay, quick point, like these are very standard points, but may not be very obvious when you connect storage. Now, because one NPUs per module, if let's say a customer thinks that, you know what, I'm going to use my 2 modules to connect all the storage port, it gives a decent amount of HA, and it works well. But with analytics, think about this, right? If you just connect all the storage ports to 2 modules, the NPU on the 6 modules is sitting idle, while the NPU on the bottom 2 modules may be overutilized. So with that point, one of the new things, or which may be a different things that they have to do or they should do, is spread their storage ports across all the modules. So previously they could maybe 4 modules would be more than enough, right? That gives them enough HA. All 4 modules going down at the same time is like very rare. But now, more than HA, there's a new reason for spreading their links across the modules, which is the NPU that's sitting on those modules. Okay. Similarly,
Fresh, that should be standard behavior anyway, right? I don't have an account that we don't do that at today. So whether it's NPU or not, I think that behavior is best practice at Cisco to spray all storage ports, all ISLs, and if it's a collapsed core, servers across all ASICs within all the blades in a box. So I'm a little confused as to why we should be doing that as a natural event.
Well, yeah, but hold on a second, Mark. I mean, I think what's important to realize is that some customers have mixed chassis, right? They have some 16 port blades and they have some 32s. And so I think what Paresh is trying to highlight here is that if you bring in those 32s and you want to do analytics on those, we may be in a position where we may use up some of the capacity of the NPU. So I think wherever possible, try to spread those connections across, right? I mean, I think you guys all know that from an architectural perspective. It's also a differentiator against our competition, right? With their architecture that they have from a limitation perspective. So I think it's understood by everybody that you should always do this in almost every scenario, but I think it's worth pointing out for those scenarios that, may be a little bit sort of a corner case, if you will.
Okay, that's fair. Yeah, I didn't think about the 16 gig line card, but that's a fair point, Art. Thank you.
Yep. And this is very obvious for this team. I don't believe anybody in this team is not aware of that. Like customers, at times I've seen, hey, you know what? I've got all my storage port connected to the bottom 4 slots. Is that okay? And like, yeah, that's fine. But then now, if you have 8 32 gig modules and you have enabled analytics on the storage ports only, what they'll end up doing is they overutilize the NPU of those bottom 4 slots, and then the top 4 slots would be sitting idle. Right. So, and when we explain this, that's okay. So now, it's a different thing, a slightly different thing. Okay. Yeah, but yeah, for this, you shouldn't be surprised. Yeah. Similarly, when we talk about 2 different switches, again, if you have more number of storage ports connected to one storage edge switch versus the other, spread it. I mean, every design that you're seeing here, these are just examples, but the end goal is spread your NPU or spread your analytics capability as much as possible, because people are paying for it. They have the capacity, they have the compute capacity of the NPU. We don't want it to sit idle while some of the plates we are, going over the board. Similarly, for host ports, right? Same point. Don't stick to few slots. Only spread it as much as possible. And that brings us to one of the questions that, hey, I can do it with storage ports. I can do host ports, assuming I have 32 gig end-to-end. Which one should I pick? Because we also know double inspection of the traffic is not cool, right? We should avoid that. So if in this environment, I've got end-to-end 32 gig, where should I prefer? Should I go to host ports or storage ports? So let's talk about that. in general, the way storage area networks are designed is that we all know that the number of storage ports are less as compared to the number of host ports. That's a general thing, depending on your fan in, fan out ratios. You can always say that, I'm going to have maybe 10 host ports per storage ports. On a very high level, right? Not a generic statement, but you guys know what I'm talking about. Now, because we have more number of host ports, we need more, obviously, switch ports to connect to these more number of hosts. And because we have more ports there, we have more modules, we have more switches. That means we have more NPU capacity on the host edge. Right? So that's one point, that we have more NPU capacity on the host edge. Okay. The second point is this, that take a very simple example of, let's say, one environment where I have 10 hosts talking to one storage port. And then because we enable analytics per port, if I enable analytics on storage port, I either enable everything or I disable everything because there's just one port. But if I inspect the same traffic on host ports, where I have 10 host ports, I can increment in 10% every time. So let's say if I enable on one host port, I inspect 10% of the traffic. If I do 2 ports, I inspect 20% of the traffic and so on. So my granularity of enabling or disabling analytics is much better on host ports. And in the very beginning, it may not be very evident. In the future when we have to, get very specific, after 6 months, you think, oh, it would have been better to enable on host ports, right? So these things may not be very obvious in the very beginning, but it gets very important in a while. So watch out for these 2 points. Based on these 2 points that I said, number one, more NPU capacity on host ports because we have more number of host ports in general. And number two, the granularity of enabling or disabling analytics is better on host ports. It makes sense to prefer host ports in a generic environment with some exceptions that we'll talk next. Okay. Okay, ISL ports, standard operating procedure, what I just said, when we are enabling analytics on ISL ports, just distribute as much as you can, which probably people already do today. For ISLs, it's easier, right? Because this recommendation has been there for forever, since day one. Okay, however, there is some minor, or not minor, a major consideration when we enable analytics on ISL ports. So here is the thing. If you remember when we talked about the way we calculate metrics is that the command frame, which is going from an initiator to target, and then we need the transfer ready and the response frame, right? Let's ignore transfer ready for now. We just stick to the command and the response, right? Which equally applies for read and write commands. These 2 frames are going in opposite directions. The command frame is going from, and let me draw it for the sake of example here, right? So I have an I have a T, and we have a MDS switch here. And my command frame is going from initiator to target, and my response is coming back. If we enable analytics on ISL ports, what would happen is that because of our default exchange-based load balancing is the same ITL flow, but exchange 1 will go on the first link. So if I have 8 links in a port channel, as you see here, OXID 1 will go on link 1, then OXID 2 will go on link 2, 3 on link 3, and so on, and all the way to OXID 8, and then 9th will go on the first link again. Essentially, all my 8 NPUs will end up seeing the same ITL flow. And because we have a limit per module, that is 20,000, essentially we are counting the same ITL flow 8 times. That means my scale limit gets reduced by 8 times. Not very cool. And that's why we want to avoid enabling analytics on ISL ports in general, because of the scale considerations. Making sense? This is an important point. If you have any questions, this is the perfect time to ask it.
So for why then we do offer this as an option?
Say that again.
So, I mean, when you set up analytics on DCNM, you have the option to deploy it on ISL. So why then we give that option to customers?
That's a good question.
If this is either, design constraints or constraints on what you just explained, why then?
So we want to empower, I would say we want to empower people, right? We don't want, because it's not a solution limitation. Also, it really depends. Look, there are no good or bad choices. It's all trade-offs. If let's say somebody says that I'm going to buy a new 32 gig module and then just going to use them for ISLs, then the only option they are left with is ISL, enabling it on ISL ports, right? And at that time, you want to be aware that you're going to hit your scale limits really sooner than the other options. So it's not like this option doesn't work, but this is something that we should be watching out for, these scale limits.
Another question. And I did not think that we were guaranteed that if the flow from the initiator would always take the same path as the response from the target coming back. When you've got multiple ISLs or port channel, are they guaranteed? Are you guaranteed that the responses coming back for the same exchange will all be over the same path?
Tom, hold that question for 5 more minutes.
Okay.
Okay, so moving on. So overall, the point is on ISL ports, because of the default way of our exchange-based load balancing, every exchange of the same ITL flow may end up taking different wire. And because we always recommend our customers that spread your links across different slots, that means the same ITL flow will show up multiple times on the same switch on different modules. That will bring down our scale. Still a very valid option, but there is a trade-off.
So are you saying that's kind of a false positive then?
No, just like it's a lower scale.
It's one more time. I apologize. What was that?
It's lower scale.
Okay.
So I mean, here is a simple example, right? The switch has 40,000, right? If and if I have 5,000 ITL flows, 40K, if I have 5,000 ITL flows going end to end, and my cables are spread across 8 modules, I would have on the switch multiplied by 8. Right?
40,000.
Right, so this goes to what, 40,000, right? So with 5,000 flows actually show up as 40,000 flows on the switch, which brings down my scale. It still works great, no problem. Like your metrics are still being calculated, right? But then, yes, scale is a challenge.
But so when the 5,000 flows though could be from, all the ISLs you're saying, essentially, right?
Yes, I mean, yes. I mean, every new exchange will take up this new wire or the new link.
Right, but I guess the point is every new exchange would take another wire. We know that. The point is that server that's initiating the read data potentially could be using every one of those links, essentially, right?
Mm-hmm. Yeah.
So wouldn't it be better to just focus on the server than the ISL ports?
Yes, yes. That's why we have 3 models, right? You can enable on host ports, ISL ports, or storage ports. Yeah. But there are some caveats, right? Like there's no simple path forward.
Yeah, I would just think that either server or storage ports would be ideal for looking at analytics versus ISLs, because they're going to drive up the scale number, like you say here, and you're going to get more myopic data from the server and the storage, I think, right?
Yeah.
Okay. I'm just sanitizing my own thinking here. I don't know, you know.
No, this is perfectly, you're perfectly on the line. Yeah, this totally makes sense. And that's why, I mean, most of the times, you know, if you don't give me any detail, right, without any detail, my first guess would be try storage ports, right?
Okay.
And if you give me some more details, maybe I prefer host ports because of the reasons that I shared before, like here, host versus storage.
Sure.
But then ISL port, like, you know, because of the what I just said, it's the scale thing.
Yeah. All right. Well, that's cool. I mean, I think well, just let me reference yesterday's conversation with Vertana. They are more interested in server and storage ports than ISLs, right? I don't think that question was asked yesterday, nor did I hear them saying that they look at the ISL connectivity as much as the server storage anyway, right?
So with Vertana,
did anyone else hear that? I didn't see them focusing on that.
Yeah, with Vertana, they only support enabling analytics on storage ports.
You're talking about not server ports, though, ever?
Nope. So among these three models, with Vertana, enabling on storage ports is the only option. Okay. With SAN Insights, you can do all three of them. Now, I'm not saying one is better than other. I'm just letting you know.
Okay.
Okay.
I was just under the impression they looked at host ports forever. I guess I may have missed that, but
no, I think it's not that. So they are monitoring those ports. They are not collecting the flow metrics from those ports.
Okay. Okay,
right?
That makes sense.
The difference is that.
Okay.
Yeah.
Thank you.
Okay, so moving on, when we talk about ISLs, this is the biggest point that you should be aware. And Tom, this is about the question that you just asked. That when we have two MDS switches, it's the same product line, the kind of hashing algorithm that we use ensures that the bidirectional traffic ends up taking the same physical link. Okay, but the moment we connect a MDS switch to a non-MDS switch, it may be a Cisco product, but the moment it goes beyond the MDS product line, that includes the Nexus products, and which also means UCSFI, there's no guarantee that the bidirectional traffic will end up taking the same path. That means it's very well possible that the command frame, which gets from initiator to the target, will end up taking wire 1, while the response frame will end up taking wire 2 of the same port channel between FI and MDS. And because of this reason, we don't recommend to enable SAN analytics on host ports when those host ports are connected as F port trunks or F port channels to UCSFI. Even though technically these ports on MDS are F ports, they are host ports, technically, right? Somebody can say these are host ports, but don't enable analytics here because of this reason.
Thank you for the clarification.
Now, the next question could be, okay, so what can possibly go wrong? Nothing. The data traffic is not impacted, right? That's the point. Like, one thing that I want you to understand, don't think this is a typical data network design conversation. No, it's only analytics conversation. The data traffic is flowing perfectly fine, no problem, right? The analytics metrics will be skewed. And I'm not saying they are wrong. They'll be skewed, and that's a very detailed topic. Probably if the time permits, not today, maybe tomorrow, we can go and deep dive into that. Otherwise, if you have a customer, they still want to do it, like reach out and we can have a one-on-one detailed conversation. But this is not something, this is no absolute thing. I'm not saying the metrics will be wrong. All I'm saying they will be skewed. And that's why personally I'm against putting this recommendation in the official documentation, because what happens when we put recommendations there, eventually after 5 years, nobody will remember why this recommendation is there, and then the word gets spread out, like nobody knows why it happened, but now nobody wants to do it. We all know so many recommendations like that has been floating around, nobody knows why they are there, right? But this is more of a guidance that don't enable it. If you can enable analytics somewhere else, let's say storage ports, but if you have to do it, some of the metrics will be skewed, but it may still work.
A recommendation with the reason, the rationale for that recommendation together would mitigate the problem of no one remembering.
Yeah, totally agree with that. Yeah. Right. So that's why like this explanation is also part of the Cisco live session, because I totally agree this needs to be external, not just like within this team. Right. But what I was trying to say is like totally saying that don't enable it there. And I'm not in favor of making that blanket statement without really explaining it. Right. So yeah, I think the reason is important, that why it's a recommendation and why it's not. But the internals are like this, that between two MDS switches, if you go here, this previous diagram here, right, between ISL ports, in this example, I've got two MDS switches. So it always ensures that the command frame, which is going from initiator to target, and the response, which is going from target to initiator, ends up taking the same physical length. But the moment we connect these ISLs between an MDS product and a non-MDS product, including Nexus and UCS, that guarantee is not there, right? It may work, but the metrics will get skewed. And that's why we shouldn't lead with this option. Okay, so in this example, don't enable analytics on the options shown on the left of the slide. Don't enable it on F port trunks. Don't even enable everywhere, because we don't want to double inspect the traffic. Prefer your storage ports. That's what you see on the right. Okay, talking about a single fabric switch, again, the same point, just drawing the representation part of it. Don't enable analytics on both the storage and the host ports. Just pick one. And if you have to pick one, pick the host ports, what I said before, as long as your host ports are not FI or going somewhere else, some kind of switch in NPV mode, right? As long as these are rack mounts connected to the HBH directly, that's the way to go. Okay, large edge core design, there could be a couple of options, and it gets quite complicated coming here. You can, let's say, assuming you have end-to-end 32 gig infrastructure, you can enable everywhere. But just because you can doesn't mean you should. So don't enable it everywhere, right? Inspecting traffic just once in the end-to-end data path is enough. Okay, so what would be your factors? Couple of points. Number one, if you can and do storage ports, just do that. That's one of the very valid options on the very top. The other valid options is if you can and choose the host ports on your NPV switches that are connected to your servers, pick that. However, you're going to exclude those ports if you have UCSFIs or Nexus, or ISL ports is a very valid option, but you know the trade-off with ISL option. Okay, I'll convey in the next slide. Probably I should remove something from the slide, which are always, you know, these slides, there's something that needs to go away. And for those of you who noticed what I just did, you know, you're going to find an answer of that in like maybe 2 minutes. So don't enable on those NP ports, right? The links between your NPIV parent and your NPV switch, which we call as generally NP port, right? Don't enable analytics there. It's not supported, right? And I have a dedicated slide on that. So essentially mix and match. Think about those trade-offs that we talk about. Storage ports, as I said, sounds safest, but eventually what would happen in a large environment, you'll run out of your NPU capacity on your storage ports, and then you need more. When and if they become T-series switches, right, then you have 100 of these NPUs sitting at every top of the rack. Well, why not utilize them, right? So that can be a very valid option.
Yeah, I don't think they're going that way. Now they seem to be going to reverse their direction and going to a lot of the 9718 islands.
Okay, see that?
Ching,
All right.
Ching, ching.
Okay.
Yeah, but yeah, they're right. That'd be great if that's, well, it would certainly be a solution.
Yeah. Okay, and this is again, like I would say, an advanced technique. So what happens, let's say in this example, as I said, somebody enables on storage ports and they run out of the NPU capacity, but at the same time, they'll be having a lot of NPU capacity sitting idle at the host edge. So this is where it becomes a manual way of deploying it. Figure out where your zoning is there, where your traffic is going, and maybe you can find some of the host ports which are sitting in zone 1, and then you find some other target ports which are not sitting in zone 1, maybe zone 2 and zone 3, and then selectively analytics, so that you maximize the utilization of your NPU without really double counting the same traffic. And there's no easy way of deploying it. You have to analyze your zoning, you have to analyze your traffic pattern, and then it. This, I would say, may be a futuristic option when you run out of your NPU capacity at one edge and you're sitting with idle NPU capacity somewhere else. But hopefully this point is making sense. Like, it's an option. There's no easy way of making it happen, but it's an option. Okay, and this sounds like a fairly, talked about topic. That what about and enabling analytics on, storage virtualization devices like VPLEX or SVCs? So there's no magic bullet, first of all, right? I don't know what to tell you. Like, I don't think anybody can tell us like this is what needs to be done. But then there are some trade-offs and considerations that we need to be watching out for. In general, these devices, these storage virtualization devices like SVC and VPLEX, they act as a target for our servers, and they act as an initiator to the storage arrays. Okay, so there are considerations with the number of ITL flows. There are considerations where you connect these ports, because if you hit these ports on the same module, you'll have too many ITL flows, and the same port will be listening to or maybe connected to the target as well as initiator. Now, I believe we have a lot of experts on this call. If you guys want to contribute, like, just yesterday, I think when I was talking to Wolfgang, you were saying that, SVC uses the same physical port for initiator and targets, but VPLEX has dedicated ports for targets and initiators.
That's correct. That's the best practice deployment, yes.
Yeah, so in that case, because they're dedicated ports, you can connect those ports to a different module to utilize, or different switch to utilize a different NPU. But if you have the same port, it's a single wire, guess what? Your same a target port will also be an initiator port, right? So when you enable analytics on that port, you have 2 flows at the minimum. That means you're double the number of flows. Kind of like, I'm not saying that's the logic. That really depends on the logic of that SVC device, whether it creates a single IO to write to the backend storage, or does it create multiple IOs? That's really implementation dependent, but there are some considerations, and these are the same considerations that we have talked till now.
Yes, my question is, you are explaining that there may be some challenge with IBM SVC. Okay, so what's the solution? Should we say no, do not enable some analytics with SVC, or do we have a best practice around that?
No, we don't want to go and say no, because that's not reality. There are some considerations with scale that you need to be watch out for because of the way these devices work, right? So imagine if you, let's say, let me create a new slide because it's looks like it's going to be takes a bit of drawing here.
So it's just a scale issue. It's not about confusion. Sun Analytics will not get confused.
And then you have your storage here. Right, and let's put MDS here. Okay, so if you move from server, you come to a fiber channel switch, and from the fiber channel switch, you go to SVC. Okay, and then again from the fiber channel switch, we go to the backend storage. So if this is I1, this is T1, but then the other I1 T2 is, this can be an I2 for this T2. Okay, so now how many flows we have here? I1 T1 and I2 T2. Okay, so this is one point about scale. The other point is in SVC, because the single port, like at least that's what like looks like the way it works, but let me know if it works differently. But with VPLEX, what I've been told.
But Parsh, at the end of the day, it doesn't make a huge difference, because on VPLEX, even you have dedicated ports acting as initiator or target, because you also want to enable analytics between the VPLEX and to the backend storage, right? So I think from the flow point of view, it doesn't make a huge difference.
Yeah, you can throw it on different modules, right?
Of course, yeah, you have some more flexibility in distributing the ports across line cards. Yes, that's correct.
That's one option. The other option, now you can throw it on different switches if it's that large as an environment, right? That's other option. So these are some consideration. I think the biggest consideration is about what do you want to monitor? And based on that, you're going to enable your monitoring, because let's say if I monitor on my let's say host port here, I actually monitor the performance between server and SVC. Based on the fact that SVC doesn't really wait for the write to happen or the read to happen from the backend storage, right? And I don't know, this can be very implementation dependent, right? Does SVC cache the write? Let's say if the server originate or I1 originates a write command, when does the response is sent back to I1 by T1? Is it sent when SVC has received it, or is it sent when the data has been written to T2?
Yeah, so this is Hiren. Yeah, so SVC and VPLEX, they work very differently. Actually, I'm a former storage architect. So SVC, you have the, basically 4 or 6 node cluster. So once the write comes in from the server, SVC will acknowledge that write, will replicate that write to another SVC node to have a mirror write, and then responds back to the server. And then later on down, it will destage it back into the backend array. Now, that's how SVC works. VPLEX works complete opposite. VPLEX works more of a write-through model. Where writes comes in, will hit the VPLEX cache, and VPLEX will write in the backend array. Once that write is acknowledged by the backend array, then it will send write complete to the server. So it's a little bit different architecture than the way they operate.
Okay, thanks for that. So hopefully it making sense for all of us, like really where you enable based on that, like based on the architecture of a device, we measure that performance. With SVC, looks like if you enable analytics on the switch port that's connected to I1, we measure the transactions between or performance between I1 and T1. But if there's a slowdown between SVC and storage, we'll miss that.
Now I have a customer, a very large customer for us, I think, and you probably heard about it. So right now is pretty large MDS shop and a couple customers. They all the way architecturally they have been using VPLEX across their agencies, where they will just basically have multiple backend arrays, and now obviously different types of arrays. If they use the MDS architecture, what we've been proposing is to have more of a 2 separate vCenter architecture, front end and back end. Because technically, when the servers write, they're not writing to the arrays, completely virtualized behind the scene, behind the appliances. So how will Center Analytic will cross a vSAN? Like say, for example, if I have a front end vSAN, well, I have a server to appliance vSAN because I have a dedicated port. This is specifically around VPLEX architecture. And then I have a backend port that from my VPLEX to the array, another vSAN, completely separate isolation, because the backend array will never need to talk to the server at all. So we have to provide some type of isolation security, more of a zoning changes architecture. How will that play in analytics? Will MDS, I mean, how does that will work?
Is that right understanding, something like this?
Yes. You have a vSAN 10 going from your VPLEX front-end ports connecting to the server, and then you have a back-end port connecting to the back-end storage. Yep, what you just draw in the green color, that's exactly what I'm kind of, trying to get some ideas around analytics.
So I would imagine if you enable analytics between I1 and let's call it as VT1 and VI1, the VPLEX ports for our reference. And I would imagine if you enable analytics anywhere between I1 and VT1, subjected to the same considerations that we talked, it will actually show you end-to-end, because what you said that VPLEX actually waits for the response to come back from the backend storage.
Right. Yeah.
And so is the case if you enable analytics anywhere between VI1 and T2, because it's still the end-to-end IO between my I1, like originated from I1.
Okay.
But the other point is the what do you see on the wire, because you're not, when let's say if I enable analytics on this 2/1, which is connected to VI1 on VPLEX, the flow that we see here is VI1, that's my initiator, and my target is T2. I don't see I1 here, right?
Yeah.
However, if I monitor here, I see I1 and I see VT1. I don't see T2 here. So that becomes very interesting that as a user, how would they, make sense out of it, like where the flows are going? Because there's no automatic mapping, right? SAN Insights is not going to map this end-to-end mapping, right? It just knows about ITL.
Well, yeah, I mean, that's, I guess it's a blessing or a curse, man, because that's the way it works is great, because you have the appliance that's completely isolating the server connectivity as well as, storage refresh or migration or performance issue. You can eliminate with VPLEX. But I think when you bring analytics in a certain corner cases, you're going to have a lot of disconnect.
Yeah,
and you couldn't even manually put those together. I mean, because those flows are going to be masked between vSAN 10 and vSAN 20. It's not going to be one straight flow, right?
Yeah.
So even if you wanted to put them together manually, you wouldn't be able to. Like, say, what is the total round trip time from server to storage through a VPLEX? You would have no idea because it's two different flows.
Yeah. Mm-hmm. Yep. And most of the time when, server team will be only looking at VPLEX and, from the storage analytics perspective, let's say from the storage team, only thing they want to justify is the server, their IOP, the millisecond latency they're expecting, is it optimal, right? They don't really care. Is it VPLEX? Mostly they're looking at VPLEX. And from the scale perspective, I think the vSAN 10, like the front end, is what we will mostly, I would probably will monitor it first before I go down to the back end storage.
But I'd also expect you to have potentially vastly different write times versus read times. If the VPLEX is caching the writes, I don't see how it would cache the reads. So it would have to go all the way through to get reads and stop halfway to get writes.
Yeah, it does cache its read with the algorithms, but the writes, so they want to guarantee the write actually gets there where it should be, which is the backend IO, backend disk array. So that's the fundamental. I have actually competed against SVC for a long time myself because of the fundamental architectural differences, right? But that has some benefits and some issues, right? Because now you've got additional latency on your IO or VPLEX backend array. Yes, the latency, but then you guarantee that your write is made it to the backend array. Versus SVC, it mirrors the write across another node in the cluster. Hopefully you don't lose all your SVC node at the same time. If you do, then you will lose that write. Right.
Okay,
But,
guys. Yeah,
okay.
sure.
Is there, do you guys have a SVC or a VPLEX in the lab somewhere that we can kind of, because I'm very interested to see how this flow will look.
Yeah, we do in the Introp lab. So I think, yeah, let's work on that.
Okay.
I think this is a great conversation. So at least it got everybody's mind spinning in that direction, that what we are going to do. So I think this is a good activity to do, and like write some more notes and some more guidance on it. Okay, so I'm going to save this thing so that, you know, when you guys get this recording later, you know, we draw something, right? So I'm not going to delete that. Okay, I think let's move to the next topic, which is about capacity planning and what happens when NPU goes beyond. This is also has to do with that. How do you enable analytics in steps? Don't just go and enable it like from SAN insights and then SAN insights gets bombarded, things like that, right? So yeah, we already looked at this, not a surprise. So I'm going to move forward that overall you can enable it like anywhere, but remember the number of modules and the number of NPUs per module or the switch. It's one per module or per switch. Okay, so how do you monitor NPU capacity? There's a show command, show analytics system load. I have the output here because this is one of the crazy output. You see the number of ITL flows. It's coming from a live switch, by the way. It's not a canned output. I didn't edit it. Look at the number of ITL flows, 130,000. This is a proof we can go beyond 100,000 per switch. We don't support it yet. Look at the NPU capacity on 4 modules, 1, 3, 4, and 8. We are hitting 100%, right? All of them. Okay. And when this happens, there is a syslog generated, which looks like this. I cannot show you because I don't have 100% NPU capacity on the switch. But we also send this syslog to DCNM and it shows up there. So to log in, if I log into the switch and
Paresh,
can
you explain the fact that in some modules you see 100% MPU utilization, in another one you only have 5%, but if you compare the number of flows, it's not so different.
Yeah, that's why there are two attributes. One is not dependent on the other.
Also, is it a question of active flows as well, Paresh?
I'll answer that. I can answer that question right now. The NPU load is not a function of, okay. NPU load is a function of active IOs that are happening right now. Okay, so if I execute this command, next second, this number may change from 19 to whatever. Okay, this is active load right now. The number of ITL flows that you see here is the number of flows or the number of flows that the NPU sees or that remains. And then there are concepts like purging the flows and clearing the flows. We'll talk about that. And there are more details to it. Like what we send out of the switch is like there's a differential way where we say that just send whatever changed. Don't send everything. We'll talk about that too. But without going to those details right now, this is the command to check it. And at this point, I'll also say when you enable SAN analytics in production environments, especially with large customers that you guys must be working with, don't enable it from SAN insights directly. This should be your first step. Okay, but you can execute this command only after enabling analytics, right? So that's a catch-22 situation. And we have a solution for that too. So let's go on another switch. And I don't have analytics here, right? Oh, I have. So let's disable it. Oh, no analytics type, FC SCSI, all right? One single command to enable or disable it. So we enable and disable. So just to be sure that I don't have analytics enabled on any port. And then there's a command. You have to run this command, you at least have to enable feature analytics, right? That's the standard NXOS function. Otherwise, none of the analytics commands will work. And then there is a command show analytics and analytics help, which tells you about what is the exact syntax, which is NPU load or something, evaluate NPU load. So this should be your first step. If you want to enable analytics, anybody who wants to enable analytics, this is the first thing you should do. And you're going to see the output right here. What happens? I don't have analytics enabled on the switch. I want to enable, but before that, I want to see what's happening. How much NPU load, how many ITL flows, where, which port, which module, where. Because as I said, no customer that I've ever talked to knows the number of flows they have, because they never were supposed to know this detail. They were only supposed to know floggies and FCNS and end devices and storage. That's it. Then flows are much more than that. They are like about number of LUNs that are flowing on the IOs, right? So essentially this command, we'll talk about this show analytics command more. It's a Python utility written. If you open and read the Python code, you'll see that, and internally this command is enabling analytics. Let it run for 2 minutes, see everything, collect the output, disable analytics, and dump the output here. That's the logic in it. And by the way, you can totally modify. We'll go through those details too, if not today, maybe tomorrow. So,
hey, Paresh, back to your slide on module 3. I think it looks like you're at 100% NPU load and only 8,700 flows. Is that right?
module 3, 8,700 flows. Yes.
So, I guess when we were talking about limits on number of flows per line card, they're 20,000 per line card. So that must be a variable, right? How do we get 100% NPU load with under our maximum number of flows on that line card?
No, you cannot get that. It really depends on the IO pattern, the kind of IOs that are being originated by the end devices, and I don't believe we can control that. Some devices may have different IO patterns. We have talked about all these details, guys, like IO sizes. If I have a large IO, I'll be doing less number of IOs. That's how applications work, because there will be too much of data going back to the same application within a single IO. But if I have a smaller IO sizes, then there would be transactions, and think about what's going to the NPU. We have talked about this. Only command frames go to the transfer readies, go to the response frame, go to. If I have 64K read, I don't send all those 32 frames to the NPU. I just send my command and my first response that's coming and the response. Right. So those are the low level details. Again, those are engineering implementation detail. Probably, so we can have a follow up if you want to go in that level detail. But the point is that these are two independent attributes. One is the NPU load and ITLs. None of us can control that because these things are controlled by our applications and the customer's deployment. But we can monitor that, and accordingly we can design.
Okay.
Okay, so this is the output that I get from this command, right? It tells me the number of flows on FC1/15. It tells me the NPU load because of SCSI traffic, NVMe traffic. I got nothing, which is totally fine. And similarly, it shows me on the other port to 2/16. So now I know where to design. So if you enable analytics from SAN Insights on this switch, I would be totally okay. But imagine had this number instead of 3,619, this would have been 36,019. And then here also I see 36,019. Okay, so I wouldn't like to enable on analytics just like that from SAN Insights. I like to go in step-by-step basis. Okay, so very important command. Remember, this should be your first step. Right, and there's no side effect. I'll execute that command again. Let's see what's in the running config. Nothing, just before the command. So as I said, it enables, it monitors, it disables internally. Okay, so export mechanisms, we have seen this before. We have some CLIs. I'll execute some more CLIs. The same CLIs that you can execute on the switch, you can run via an X API too. I'll probably show that, and then we have streaming telemetry. Yeah, so 3 approaches. Okay, now more than that, what are the approaches? Some more internal detail, and that hopefully helps to realize that what to use when, recommendations. So guys, when we talk about push and pull, I know we have used these terms very generic, and that's totally fine, but still there are some more details. When we execute a command on the switch, you remember those show analytics queries that I was executing last week when we covered NPU DB architecture? they are always pulled from the NPUs. Okay, when I execute the command, hit enter, the query goes to the NPU and pulls the metrics. And the switch internal logic figure out where the logic, where the flow is, right? If I use a where initiator equal to something, the switch figures out where on which NPU the initiator is being seen and gets the data back from it. We don't have to worry about it. NX API is exactly same as the on-switch CLI. The only difference is we execute the same query that we have been executing on the console on a remote machine, wherever we are making that request, just that it's coming over HTTP. However, there's an additional level of detail with streaming telemetry. The streaming telemetry is a push mechanism from the switch, but within the switch, between the supervisor and the line card, there's nothing like a push from the NPU. Okay, when the query timer is hit, the supervisor sends a query to the NPU, the NPUs respond back to the supervisor, and the push happens from the supervisor to our remote receivers. And we can have up to 2 receivers that we support as of now. And we can have more, but I'm just talking about the supported number. So the push is happening from the switch to the external receiver, but within the switch, between the supervisor and the NPU, it's always pull. Okay, so what are the recommendations? When do you use when? You would use show analytics command, the overlay command, when you're doing on-switch active troubleshooting. That is your way to go. SQLi queries, I don't know, like if any customer would like to use it, first of all, the output you guys have seen, it's in JSON format, not very cool for eyes. Also, the metrics that you see there, you see most of the metrics were accumulated metrics, the total IO count, the total time, IO time, and the initiation time. The only metrics which are relevant are the bandwidth and the rate, which is IOPS, over last 4 seconds. Okay. When we talk about remote agents, NX API, even though it works, but again, just because we can doesn't mean we should. And what I mean by that is don't use NX API for a continuous export of metrics at scale. If somebody has a script that watches some of the metrics at limited scale, yes, use NX API because I feel it's easier to implement. But if somebody wants to access the metrics all the time, forever, every 30 seconds, streaming telemetry is the way to go. That's what DCNM uses. That's what the virtual wisdom uses, and that's what our recommendation should be. Okay, same detail that I just said. Okay.
Sorry, I keep getting double muted. Sorry. For the NX API, would you use that for things like maybe once a day, once a week, looking at kind of capacity planning for which initiators potentially are sending out more requests or IO for that week or something like that?
Yeah, something like that, right? Let's say, I mean, I want to figure out how many targets a single initiator port is talking to. Now, I don't need that information every 30 seconds, right? Maybe I'm good with once a day. Things like that, right? Like use cases and less number of metrics. Don't go and pull every ITL flow via NX API. I mean, I don't know the side effects of it, but you guys are smart enough not to do that, right? Something like that. Yeah, things like capacity planning is a very good example that you said there. Okay, so you already know how to enable analytics from the CLI, right? Like I won't do that again, but show, no, what's happening here? Show run analytics. If you look at the output of this command, you need to execute feature analytics, and then within the interface, just one command is enough, right? If you go in the interface, there is the analytics type. You can do FC all too if you want to do for all. And by the way, there's no downside of it. But in the future, I would imagine, let's say if the NPU capacity is more and somebody says that, you know what, I want to inspect NVMe traffic. I don't want to really do SCSI anymore. That would bring down my NPU capacity. So this can be one of the options. Okay, then system load. After you enable analytics, there is this command show analytics system load. you can use this. So now it shows me the same thing. But the other command, the show analytics, let's execute this command now again on the switch where I have enabled analytics. You're going to see something interesting here. See that? I cannot run this command after enabling the analytics. So there are different use cases for both the commands. Okay. And this is a safeguard mechanism that you don't want to overload NPU to do the same thing, because we have the output as part of the show command, the standard NXOS show command. That's why you don't need this show analytics and evaluate NPU. Okay. So use the right command based on where you are in your deploying. Once you have enabled analytics, at least on one port on the switch, go with the show analytics system load command.
Maybe another question to that one, Paresh. Can you go back to the CLI, please? Yeah. So this overlaid NPU load. So it turns on the analytics feature, and then it scans each individual ports for a few seconds. Is that what it is doing?
Yeah. This command.
So, because and how does it? Yeah. So I wonder why I only see here the 2 ISL ports.
Okay, good question. Let's see. Oops. Let's see what do I have in the switch? I got 32 gig module on slot 1 and 2. Okay, and let's see what do I have on slot 2. So
okay, that's
the only
okay.
port
You only have the
yeah.
TE ports on those cards. Okay, that's the reason why.
None of the other ports are up. If you have more ports though.
Okay.
Yeah.
Okay, I just want to make sure that I misunderstood this feature, because we only saw the ISL ports, but there's nothing hanging off the other ports that explains it. Okay, thank you.
So would the show NPU load, would it show the potential ITL flows for interfaces that are not currently showing analytics? Because we have to enable analytics on each interface. So before a customer turns something up, they can do, the show or the Python script, right?
Yeah.
But after that, can we show, before we turn on a port and add to the NPU load, can we show that what that load would be? Or is it's one or the other?
No. Once you enable it on one port, you cannot run the Python utility. Analytics, you cannot run that. So,
but from a system load standpoint, if you had other connections, would they show up here with their ITL flows?
No.
Or they wouldn't until you
analytics
turn on
enabled ports. Yeah.
Okay.
Only analytics enabled ports show up here. So
really,
maybe
as they ramp up, they should be turning on ports at a time and then rerunning the system load command to make sure they're not overwhelming something on the NPU side. Like
that's one of the options. Yeah. I mean, there's no side effect of it, right? Like, let's say you enable it, you let it run for 5 minutes, you disable it. That's a valid option. However, I would believe, let's say if I run this command today, it's going to show me, because the traffic, how much can it really change, right? Like, let's say if I know my peak time is Monday morning, I run this command Monday morning, and then I have a sample output at least, and then I can have some estimation at least, right? And then the second estimation is what you said, Greg, that you enable it, let it run 5 minutes, and then disable it, and then get the output from the other show command, which is show analytics system load. This only shows you, and by the way, it's not showing per interface. I believe there's an interface equivalent to of this command, but may not be.
Okay.
Paresh, do we have what type of load this puts on the CPU on fabric switches and or the SOUP?
Yeah, I have some, QA has some results on that. It's not much actually, because remember, though the CPU only gets involved when it comes to exporting these metrics from the switches. right? So let's say every 30 seconds when we export this via streaming telemetry, so you'll see the CPU gets spiking. Let me do the show processes, CPU history, right? Nothing. And how many flows I have on the system? Around 3,600 something, right? If I go on another switch, so you see that no CPU spikes that you see on this switch, right? It's exporting everything. Show analytics system load. And here I have around, like, total is around 5,000 flows, 4,989. And if I do show processes, CPU history, nothing, right? So yeah, I see some, you see this, like, so don't be surprised if every 30 seconds your CPU spikes, like, kind of like, you know, slightly, you know. So yeah, there would be telemetry process, this process that would be doing things. But yeah, I mean, none of that I would be concerned about. These have been, you know, topics of, like, you know, where we hit the scale and like why Q will test, and like at the last minute they'll back off. No, I see a CPU spike. Okay, next please. You know, you guys know that whole story, right? So
I did have another question too on the fabric switches. Well, on 9148T and 9396T, they have 2 network management ports. Is there any guidelines or any best practices about maybe exporting telemetry out management 1 versus management 0?
okay, so great question. Let me tell you the backstory why we have this second management port on the switches. When we were building 9132T, and that was the first switch in the 32 gig product line. I'm talking about the switch, not talking about the module, because the module doesn't have a management port. That was the first switch we were building, and it was almost the hardware finalizing state. And then that time we were exploring, hey, you know, how many free resources we have on the faceplate of that switch and also the backend FPGA that we are using. And we realized we have 1 10 gig spare port. So we prioritized it because in the future, we did not know back then. It was year 20, I don't know, 4 years back, 5 years back. Right. And that's the reason we came up with 10 gig port without any idea if we'll be ever using it at all. As we progressed, by the year 2018, we realized that when we use compact GPB as an encoding, we are able to export 40,000 ITL flows, 2.8 million metrics at every export, with I'll recollect the number, but a very small percentage of the 1 gig bandwidth. So looks like there is no short-term use case to prioritize that 10 gig management port. And I think that's one of our value propositions, that, you know, we are able to export so much of data with such a less amount of bandwidth and low amount of memory and CPU. So we have that 10 gig management port on our all fabric switches now, T-series switches, and later when we made SOUP 4, we had the 10 gig management port on SOUP 4 too. But eventually, I would be very happy if we never have to use that 10 gig management port. In the future, if there are more reasons to enable 10 gig management connectivity, then we may enable it. But even then, I don't think there would be a lot of, you know, interest in having 2 management ports, right? A single 10 gig management port would work. Like, there's additional complexity with having 2 of them. So for now, I mean, that's what I've been telling all the customers. Yes, that's just for future perspective, because we are building our 9700 directors for 20 years. So we don't know what's going to happen 5 years from now. And that's why we are over provisioning it. But today we don't need it. Next year we don't need it. 2 years from now we don't need it. So we'll see when we need it.
Paresh, it's interesting that you mentioned the SOUP 4. I don't see a port on that in the data sheet.
Okay.
So did they can that? Or, and because I thought there was going to be, but then I'm looking at the SOUP 4 module and I don't see a 10 gig port or a SFP for Ethernet.
Yeah, because it's not even enabled yet. That's one of the reasons, but yeah. I mean, If you want, we can mention that. Not, I mean, but as I said, we shouldn't even be leading with that. That just somebody asked that question. That's when I respond to that. Otherwise, I don't. Yeah.
Okay. Thank you.